So today is Thursday, October 26th, and we are not doing a new lesson today. We're just going to be spending today reviewing what we know about multiplying decimals and whole numbers, okay? Wait a second, but we spent this last week converting units of measurement. How is that related? Is that related to this? Did we have to multiply decimals and whole numbers in order to convert measurements? Yeah, so that's how it's related, okay? Let's start by talking about today's problem of the day. The directions tell us to write the numerical expression in words and then solve it, right? In the chart, those are the different columns. So whenever we're preparing for a test, a really good strategy is to think like a test maker. Why would a test maker put this kind of question on the test? What skills are being tested? Talk to your table group. Hands down. So this main skill is seeing if you understand what these numerical expressions mean. So looking at 1A, it says 12 times 5 plus 15. If I were to write that, does that show I know what that expression means? No. No, it means that I know what those symbols mean, and that would not be right? 12 times 5 plus 15. That's not correct. So how can I write that into word form in a way that shows what I know what this expression means? So in word form, we could write 12 times the sum, or 12 copies of, right? The sum of 5 and 15. This shows that we understand it because it finds, when we solve it, does that mean I do 12 times 5 first? No, I'm actually finding 12 copies of the sum. So what do I need to do first? Find the sum first or multiply first? The sum. So you can see if you know how to write it in word form, that means you understand what the numbers and symbols mean. So again, if we're trying to find the value of the expression, we have to first find the sum of 5 and 15, which is what? 20. And then we're doing 12 times or 12 copies of it, right? Okay, so then when we do that to find the value, 12 times 2 is 24. And we have one factor of 10, so the value of the expression is 240. On your review guide, put next to this question, number 1, 2.3. Therefore, if you feel like, ooh, this is something I'm not very confident in, you can review Module 2, Lesson 3. If we're going to compare without calculating, should I actually multiply 18 times 27 to see what the value is? No. How many 27s do I have on the left side? 18, right? So over here I have 18 27s. Okay, what about on the right side? How many 27s do I have to begin with? 20 27s, and I take how many of them away? So if I have 20 27s and I take one of them away, how many do I have left? 19 27s. So which side is more, 18 27s or 19 27s? So I need to put this here. However, am I done? No, because I need to explain using words. So what's one way I could explain? Well, I could explain what we just thought about, writing it out. I could say, well, on the left side, I only have 18 27s, but on the right side, if I had 20 27s and I took one away, there are 19. 19 of something is more than 18 of something, so 19 27s is more than 18 27s. Do you see how you could explain it using words like that? Take some time right now and write your own explanation for number 2B. We have discovered once again that this is lesson 2.3. So if you're feeling like, ooh, I don't know, I'm a little iffy on this one, go back and review lesson 2.3 again. And it makes sense because in order to do this, do you need to understand what these expressions mean? Yeah. Right? So lesson 2.3 was all about understanding numerical expressions. And that's a big part of this lesson, this module, even though it's only one lesson. You can see already there's been 2 questions dedicated to lesson 2.3. So to estimate, we can think that 3,502 is pretty close to what number that's a lot easier to work with? Supan? 4,000. Okay, it's very far away from that, but yes, we'll go with that. And 656 is pretty close to what factor that's easier to work with? Ritfik? 700. Nice. Okay, now, by the way, did we round these numbers, when we rounded the factors, did we make them bigger or smaller? Quite a bit bigger, right? So is our estimate going to be bigger or smaller than the real answer? Okay. And so 4 times 7 is 28, and how many zeros do I need to add? Okay, so our estimate is 2,800,000. But because we made the factors bigger than the actual factors, that our answer, should it be bigger or smaller than 2,800,000? Smaller. So in the very end, when we get our final product, we can use our estimate to see if it's reasonable. And as Turjo said, he found that this was less than 2.8. So you write 2.8 next to number 3, because that's the skill that we learned there. So in order to do an area model, since we have decimals, we will need to rename. Okay. We can rename 5.04 as 504 what's? Hundredths. Haley, how do we know that 504 hundredths is the same thing as 5.04? Okay, do you guys agree? 2.10?
And 2.7.
Okay, so let's put 2.10 for this one. And 2.7, is that for the area model?
Yeah.
Okay. Okay, so for this one, you're going to write 2.10 and 2.7 because those are the chapters where we learned how to multiply using an area model and the standard algorithm. This word problem is just like 2.15, so put 2.15 there. Okay, and these word problems, I'm going to confess to you, when I think of these word problems, I'm like, oh, it's so hard. But the minute I try to draw it out using a tape diagram, it becomes instantly 10 times easier. Okay? So we're going to try, we may not have time to solve it today in class, but we're going to at least try to draw a tape diagram so that when you go home, you know how to solve it. Okay? So read the problem silently to yourself and see if you can underline what the question is asking and circle the important information you need. They can't hear you, Ingrid. Try again. The question is asking us to find the total weight of both the watermelon and a lemon. Okay, so apparently we have two fruits and we're trying to find out how much altogether they weigh. Haley, what's the important information we need?
A watermelon is 9 times as heavy as a lemon. The water also weighs 1,134 grams more than a lemon.
Good, so we have two fruits and the watermelon is 9 times as heavy as the lemon, okay? And we also know that the watermelon weighs 1,134 grams more than the lemon does. Okay, this is similar to the problem yesterday, right? So if this is my lemon, I'm going to draw an L there. That's my lemon. Does my watermelon weigh more or less than the lemon?
More.
Okay, how many lemons could I fit inside the watermelon?
9.
So 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you guys see that?
Yeah.
It would take 9 lemons to weigh the same amount as the watermelon. And I can show that by drawing 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces that are exactly the same piece as the lemon. Does that make sense? Okay, is that the only thing we know about how the lemon and the watermelon compare?
No.
We also know that what? The watermelon weighs 1,000. So would you guys agree that this part right here, is this the part that extra of the watermelon?
Yeah.
Right? All that non-highlighted stuff is the same, right?
Yeah.
And so this part is the part that the watermelon weighs more than the lemon. And how much more does the watermelon weigh compared to the lemon? 1,134 grams. Okay? So how many of those sections are there that are more than the lemon? Are there 9 or are there 8? 8. So if I want to find out how big each section, each one of these sections is I could take 1,134 and divide it by 8. How could I use that information then to find out how much they weigh all together? Actually, let's just do that. Let's solve this problem. Okay, so if I know that the lemon is, the watermelon is 9 times heavier, I can take the difference, which is 1,134 grams, and divide it by how many equal sections? 1, 2, 3, 4, 5, 6, 7, 8. I could divide it by 8 sections. So I could do 1,134 divided by 8. So if we reread the question again, we can see that we're trying to find the total weight for the watermelon and the lemon. Okay, but then when I found 141.75 grams, what does that represent?
The one piece.
It's one piece. So that's the weight of the lemon. So if I know that this piece right here, oh, you guys can't see it. If I have 10 of those pieces all together, and each piece is 141.75 grams. I need to multiply that by 10. So if I take 141.75 times 10, what do I get? 0.5 grams. Because do you see how then we would just move the decimal point one spot over? Okay, very good. Now part B of the question asks you to find that weight but express it in